All right, my little friends, here we go. We got lesson 10-3, modeling quadratics. Okay, so this is going to be looking at some word problems and seeing if we can see what we can get from these quadratic functions that might show up in a word problem. So a company makes widgets. Uh, when I was in college, I was an accounting major, and like every business scenario that they would come up with, they would sell fake things or they would make fake things, and they always called them widgets for some reason. So I'm just going to use that. So a company makes widgets, so they make something, who knows what it is. And their profit can be found by this following equation. Profit equals negative 40 times widgets minus 50 squared plus 10,000. So that's the equation for how much money they're going to make. And it's based on how many widgets they're going to make. Okay, and so the problem says, what is the maximum profit? Now, maximum, that should stick out to you at some point. Maximum. That means we had graphs that were parabolas, and a maximum meant it was the highest point. And this is the vertex. Now, profit should also mean something to us. In the equation, profit is the y value. So if we deconstruct this question, what it's actually asking us is, what's the y value at the vertex? Oh, that's way easier than we thought it would be, because we know our vertex. Because remember, this is vertex form. Here's my h and here's my k. We always use the opposite of this number. So my vertex for this one would be at 50, comma, 10,000. Now, in terms of the problem that we're looking at, that means if I make 50 widgets, I will make $10,000 as my profit. So, what is the maximum, so the vertex, for the profit, the y value? My biggest y value is 10,000, because that would be the highest point of my graph if I graph this parabola. So my answer is 10,000. All right, next one says, how many widgets? Well, widgets were my x values. So I'm looking for x values. How many widgets, so how many x values, should be produced to maximize, that's my vertex again, the profits, and the profits are the y's. So I want to know how many of the x values. Well, we already said our vertex was at 50, 10,000. So 50 widgets are going to give us our biggest profit. Our biggest profit is 10,000. We know it's our biggest one because remember, this one faces down. So this point up here is the most that we could make for our y value. That's the highest y value possible up there. And y value is our profit. So 10,000 is at the top. This is the point 50, 10,000. So on that point up there, we make 50 widgets, and we make $10,000. All right, last one. What is the profit? So we're looking for the y value. When 40 widgets, those are x values, are produced. So this is asking me, what's going to be the y value when the x value is 40? All we have to do is plug it in. So let's plug that in. So profit would be equal to negative 40. W, we're saying that the x value is 40, so we're going to do 40 minus 50 squared plus 10,000. So I would do order of operations. I'd do this first. So I'd get P equals negative 40, and there I'd get negative 10 squared plus 10,000. Negative 10 squared, so negative 10 times negative 10 is 100. So this would be P equals negative 40 and then times 100. Negative 40 times 10 times 100 is going to be negative 4,000. And then that's plus 10,000. So it looks like my profit would be 6,000. Answer. Done. Beautiful. Next. All right, Hilton goes onto his roof to throw a model plane into the air. I don't know why, he just does. Sounds like fun. All right, so we can model the height of the plane using this equation. The height of the plane is equal to negative 16 times t minus 1 squared plus 32. H is the height in feet, and t is the time in seconds. So every second that goes by, that's going to put the plane at a different height. Now looking at that, I know what my vertex is. My vertex is at 132. Now what does that represent? 1 is the time, 32 is the height. So this means at 1 second, the plane will be 32 feet in the air. And that's the maximum height because look at my A value here. My A value is negative 16. So that's going to tell me that I'm going to have a parabola that looks something like that with a maximum on it. So this is the maximum height up here. At 1 second, we will be 32 feet high. Anytime before that, we're lower. Anytime after that, we're lower. So this is the highest point we can get. So this one says, what is the maximum? Talking about the vertex. Height. Oh, height is the y value of the plane. Well, there's just saying, what's the vertex y value? Well, the vertex y value is 32. So 32 feet is the maximum height of the plane. How long? That's time. Will it take before the plane reaches its maximum vertex height? So what's this one asking? Well, what's going to be the time at the vertex? Well, time is the x value here. So it looks like 1 second. That wasn't too bad. How high off the ground is Hilton when he throws the plane? Now this one, we need a little bit more thinking to go on here. So it says how high. That's feet, right? That's a height. I can't spell. Height. So we're looking for a y value. Is Hilton when he throws the plane? Well, when he throws it, what's his time? When he throws the plane, time hasn't started yet. So time is equal to 0 when he throws the plane. He's at 0 seconds. He's right about to throw the plane. 0 seconds. So we're looking for what is the height or the y value at 0 seconds. So all I have to do is plug in 0 for the time here to get my answer. So we can say h is equal to negative 16 times 0 minus 1 squared plus 32. Okay, so here we get negative 1. Negative 1 squared is positive 1. Negative 16 times positive 1 is, you guessed it, negative 16. And then negative 16 plus 32 is positive 16. So he's 16 feet off the ground when he throws it off his house. There you go. Cool story. All right, we've got one last thing that we're going to do. What we're going to do here is we're going to graph the equation from example 2 and then ask ourselves what range values make sense for this scenario and what domain values make sense for this scenario. So every single range value, y value, wouldn't really make sense in this one. And not every single time value would also make sense in this one. So let's graph it and see what x value and what y value makes the most sense for this equation. So we're going to graph it first. So we're going to make a nice little graph here. So there's a nice little graph. Yeah, so let's put this over here. Our vertex is at 132. Ooh, how are we going to do this? Let's count by fours. Let's do that. Okay, so I'm going to kind of break this graph a little bit. I'm going to make these be my time in seconds. And I'm going to just count these as 1, 2, 3, 4, 5, and so on. Now the height, since I get pretty high on this one, I'm going to do it in fours. So this will be 4, 8, 12, 16, 20, 24, 28, 32. That's going to be the highest I think it's going to go. We already have 2 points on this graph. We have our vertex. Our vertex is at 132. So let's graph that point. 132, there's my vertex. And on top of that, I know that my axis of symmetry is right here. Why is that important, Mr. Holcomb? Well, here's why that's important. Because I now have another point that we got right here, the point 0, 16. That's a second point that I have that I can use in this one. So 0, 16 times 0, height 16. So 0, 16 would be right here. And because this is the axis of symmetry, I know that 2, 16 will also be a point on the graph. So let's go ahead and do one more point. Let's plug in 3, because I know what 0, 1, and 2 are. Let's plug in 3 into our function. So remember, our function was h equals negative 16. It was t minus 1, so we're going to plug in 3. And what was it, plus 32? Yeah, plus 32. All right, let's see what we get here. We got h equals negative 16 times 2 squared plus 32. So this gives me h equals negative 16 times 4 plus 32. This gives me h equals negative 64 plus 32. So negative 32 feet. That doesn't sound very cool. Negative 32, that'd be way down here. 1, 2, 3, 4, 5, 6, 7, 8. So that would be way down here. So here's my parabola. You may be asking yourself, why is it so skinny? Well, it's because our A value is 16. It's got a really big A value. That's why this thing's stinking skinny. All right, so this one's going to go all the way down there. All right, so the question was, what range values make the most sense? So here's the original question. What range values make the most sense? Well, I know that the plane is going to be at 16 feet here, go up to 32 feet, and then come down. But according to this graph, if I'm thinking of it in my scenario, it says that it hits the ground here, and then this graph says, oh, it goes through the Earth's crust and keeps on going. That probably doesn't happen. It should probably stop right here somewhere, right? The plane should hit the ground and then just stop. So the range values that would make the most sense for this scenario, the plane could be at 0 feet, or it could be up to 32 feet. The plane's never going to be above 32 feet, and the plane's not going to go through the Earth's crust after it hits the ground. So the range values that make sense, the lowest range would be 0. The highest range is 32. So my heights that make sense are between here and here. So from 0 to 32, and here's how we write that. The y values have to be less than or equal to 0 and less than or equal to 32. What this says is y has to be bigger than 0 or equal to it, but at the same time, y has to be less than 32 or equal to it. So it's less than 32 down here, it's greater than 0 up here. These are the y values that make this the most sense. Less than 32, but greater than 0. Those y values make sense for my scenario. Now, what are the x values that make the most sense? Well, I'm not going to have a negative time value. So my x values need to start at 0, and then they need to go until they hit the ground. We're just going to guesstimate that point right there. It's before we get to 3 seconds. Want to call just 2.5? That sounds good. Let's just call that about 2.5. So the domain values that make sense for this one would be anywhere between 0 and about 2.5. We're just eyeballing it right here. So our x values could be between 0 and about 2.5. That's an approximate. So we would say x is less than or equal to 0 and less than or equal to 2.5. That makes the most sense for this scenario because once it hits the ground, it's not going to change its height anymore. And that's going to be at about 2.5 seconds. I don't know. We're eyeballing it here. So 0 seconds, he throws it. 2.5 seconds, it hits the ground. That's probably, for this scenario, the most likely time that we would see. That's all I got for you today. Math hard. See you later. Bye-bye.